So here we go. So our focus today is to take a look at some of these worded scenarios for equalities and inequalities. All right, and then really have an idea of how to model them. Okay. So we're dealing with a two variable situation, independent versus dependent variable. Okay. Let's read this first business scenario, and I want to see if you guys can model it correctly. So it's all about Uber. Anybody ever done an Uber ride before? Where do we do it at?
I think in Chicago.
Yeah, in the big cities.
Yeah,
That's where it's very handy.
Right.
Yeah. I mean, I know it's kind of intimidating because like it's not it is a taxi service, but they're cheaper than the city taxi services. So like big cities, it's a nice business because you can do it on the side. You just chauffeur people around and make some money. Okay. All right. So here we go. Let's have Ms. Brown. Why don't you read this problem for us first? Let's see what's going on here.
Uber is an American multinational online transportation network company. The therefore trip and the different services that the company offers is calculated by adding base fare, time, and distance. However, in certain cities, the company has a service called Uber Rush, and the charges are calculated on a base fare and a charge per mile. During daytime in New York City, Uber Rush has a base fare of $3 plus $2.50 per mile. Sergio just arrived at John F. Kennedy International Airport and wants to determine the function for the transportation costs during the day using Uber Rush.
Okay, so hopefully we understand the context of the business. Okay. The first thing I would ask you guys in part A, let's write a linear function describing the cost of Uber Rush. See, what would X represent? What would Y represent? What's going to affect your total cost for using the business, guys? The number of what?
Miles.
Number of miles. So your independent variable will be the number of miles. So if we understand the business, right, we understand the variables that would affect each other. So we have the number of miles are going to affect the total cost. There's your Y variable. Okay. So can anybody tell me what this function would look like? Yeah, so what would be, so the Y is your cost. That would equal what? Well, what is it per mile? Yeah, 250x, $2.50 per mile plus trace 3. Very good. Okay. So there we go. So what we've just done was we set up, in function notation, it will look like this, 2.50x plus 3. So we've established an mx plus b function based out of the business model, the cost function, okay? So I want you guys to tell me, part B says, what's the rate of change for the cost of riding Uber Rush? All right, and what does that rate of change represent? Well, look at your equation. What's the rate of change? That's a fancy word for what? The slope, right? So what does the rate of change represent? The cost per mile, right? So we need to represent, this guy is our rate of change, that 2.5. Okay, and then what we need to say is this represents the cost per mile. The rate of change represents the cost per mile. So in our function, the way we write it is actually significant. Okay? Now, notice this is an equality. All right? We don't have an inequality in this situation. So, tell me what the y-intercept represents in our function. All right. Well, no. What's the y-intercept represent? The starting fee. So we're going to jot down the y-intercept represents our starting base fare. Okay, our starting base fare. Oh, let me move that up there. Sorry about my writing. I know it's not the most prettiest writing, but as long as we're seeing it, that's fine. Okay. So from this business scenario, We got a function. We understand what the numbers mean in it. Okay. Now let's look at how to model the graph. So part B, take a peek at it, says represent the situation on a graph. So let's write our equation up at the top. Y equals 2.5x plus 3. Okay. Now this is the part I want to work with you guys because this is important to model as a graph. Because graphs, you guys ever heard the phrase, a picture says 1,000 words? Mm-hmm. It's the same thing in mathematics. Okay? If you know how to read a graph, you can interpret so many different things. Okay? So what goes on the x, what goes on the y? The number of miles on the x, right? So jot that down. And what goes on our y? The total cost. Okay? So now we're using this math in real life context. We're saying, all right, now we have a model. So we have our y-intercept at 3. That's an mx plus b form. I am going to go by ones on the y-axis. So 3 is our y-intercept. Okay? And the slope, the rate of change, right here, is that guy, 2.5 over 1. So what should I scale my x-axis? You could go by halves, or you could still go by ones. All right. Now another kind of a neat way to look at this, guys. What's 2.5 as a fraction? What is that as a fraction? 5 halves. So you could just go up 5 blocks over 2 and create a nice pretty location. Let's do that. So we'll go by ones on the x-axis also. So I'm going to do, so let's go 3, 4, 5, 6, 7, 8, 9. So let's go up 5 and go over 2. That would be the same as this slope, this 2.5, as a fraction form. And solid dotted line. Solid line. It's still, equalities always have solid lines, by the way. And we get this trend line. Okay? Now, here's the beauty behind our graph. Can we make predictions? Alright? So if I was in the Uber for 2 miles, what is my cost? $8. Okay? See, that's the benefit of the graph. I can interpret what it's saying to me if I understand what the variables represent. Okay? Now, party says Sergio wants to go to the Empire State Building. The shortest path from the airport to the Empire State Building is 14.4 miles long. So he's going to have to use an Uber rush. See, from the graph, I can't see it. But could I get it from my function? Yes. What would I plug in for x? 14.4. See how that's your input? You crank that out, you get your cost. So what would it cost Sergio to go to the Empire State Building? $39. Very good. Part F says, after Sergio is done visiting the Empire State Building and walking around, he goes to different locations using an Uber rush. Okay, so he goes to Statue of Liberty, which is 6.1 miles away. And then he goes to the hotel, which is 21.1 miles away. Total distance. What will that add up to? 27.2 miles. So in our function, if we write our equation out, this is the one we generated, right? We would say, okay, 2.5 times 27.2 plus 3. See, he'd still have to get back on an Uber and pay the fare rate again. Fare rate. All right. So what's our total cost this time? I heard Grace say it quiet. What was it? $71. That's a lot of money, right, just to get around town. But sometimes that's better than the taxi service, guys. I'm telling you right now, in Chicago, New York, you gotta have a lot of money to get around. Okay? Okay, so that's kind of neat. That's an equality situation. So let's study, I want to study a different scenario. Okay? We're going to study number 4. We'll get number 4 together. So now we got a different scenario, different business model. Let me pull this down a little bit so you guys could see this here. I'm going to have Alexa let's read number 4, and then we're going to understand what's going on. Okay.
Mara Recycling is a curbside recycling company that remains up to 200 pounds of plastic bottles and paper products each week. They charge 52 cents per pound of plastic and 89 cents per pound of paper products.
Okay. Can you tell me by what you just read what this business model is about?
How many pounds of each product?
Okay, so you're either going to have pounds of plastic or pounds of what? Paper. See, they're making their money off of what? Charging per pound. Very good. So, see, if you understand the business model, guys, you're going to be able to set up a function model to set it up. Okay? So the first thing I want you guys to understand is how do I write this? And by the way, why is this an inequality situation and not an equality?
Because there's 2 different prices.
Okay, there's 2 different prices, but there's something in the problem we have to see, right? So what do you notice, Griffin?
It says that it moves up to 200 pounds.
Exactly. There's a key word there. It says up to 200 pounds. Okay. So what inequality would that be? Less than or equal to. So this is the part I want to work with you guys on. So I understand as a student, this is no longer an inequality. This is an inequality situation. All right. So X would represent the number of pounds of plastic. So we'll just say the number of pounds of plastic. All right. And what would the Y variable represent then? The number of pounds of paper, right? So that's the other product we're charging for. So here's the deal. You guys tell me what this inequality looks like then. What would it look like as one little pretty algebraic statement? So it'd be 0.32x. Remember, 32 cents is 0.32, right? 0.32x plus, what would come next? 0.89y. And then what comes next? Less than or equal to 200. There's our bread and butter right there. Okay? See, if I just gave this to you guys, that wouldn't serve you well, because you want to be able to learn how to read it from the problem. Okay? Interpret from that problem. Okay? We're going to skip part B for right now. I'm just going to cross that one out. What I want to do is I want to just graph this one for us. Okay? All right, now we got to make sense of how to model this. So here's what we're going to do. Over in part C, it says represent the situation as a graph. So we're going to write our inequality. 0.32x plus 0.89y is less than or equal to 200 pounds. Okay? Now, important questions. What form is that inequality in? Do I have a way to graph in standard form? Yes. How do I do that? Use its intercepts. Very good. See, I have to recognize as a student in this business model, that's a standard form situation. I could graph in using the intercepts. Very good. Okay? So, block off the Y with your pen. What's the x-intercept? So you divide 200 divided by 0.32. So what do we get?
25.
All right. So let's jot that down on the side. Our x-intercept is 625.0. Okay? Now, block off the x to get the y-intercept. So 200 divided by 0.89 is, what's that turn out to? Might not be pretty.
171.
So I'm sorry.
171. I don't know.
2, 2, 4, 1, 7, 1.
Okay. That's all right. So we'll do 0, 224. We'll round it to like 0.2. 224.2.
Oh, okay.
Yeah, you want to divide there. Okay. All right, so here's the deal, guys. Whenever you graph models, you always label your variables. Always put them there, because that tells you everything about the graph. Okay. So on the x-axis, I would say, all right, the number of pounds of plastic. So we're very detailed. And on the y-axis, we have the number of pounds of paper. Okay. So you're comparing those values. Right? And the way to graph this very easily is just plotting the intercepts. So we have to scale our axes where this business model would fit on there. Okay? So I want you guys to tell me how I should space the x's. See, you're using common sense. You're saying, all right, I got to get all the way up to 625. So I need to space this guy by 50s or 100s, however you want to do it. We'll go by 50s. Actually, it's going to be kind of, by 50s it'll fit. It might be outside here, and that's fine. So here's 350, 400, 450, 500, 550, 6. So here's 6, and then the next dot over would be 650. So it's kind of a little bit off the grid. That's okay, right? We're still making sense of where that would be. So we're going to plot 625.0. That location is estimated. It's going to be that blue dot. That's our x-intercept. Okay? Now, let's plot our y-intercept. Tell me what a smart choice would be here also. 50s. Yeah, go by 50s. So you got 50, 100, 150, 200, 250, 300. All right? And we're going to put a dot at 224. Estimated location would be about right here. Okay? All right, now we got to make sense of this. Solid or dotted line? Solid. So we'll connect the two dots. Those are our intercepts. Connect them. There it is. Now, here's the tricky part. Do I shade above or below that line? And see, yesterday or on Monday when I showed you guys how to graph these, remember how we solved for y to do it? Now, here's a little trick. There's no negatives. Like when you solve for y, you'd subtract 0.32x over the other side and then divide by 0.89. Would the sign ever flip? No, you're not dividing by a negative. Okay? The hardest part is if you ever divide by a negative, the sign would flip, so the shading would go in the other direction. See, if I do that in my head, I could recognize that I'm just shading below the line. Okay? So what happens here, guys, is your solution looks like this. You're going to have everything below in green. And the first quadrant is our feasible solution range. Okay? So all that stuff in green are possible solutions. Okay? And so here's the deal. I want you guys to make sense of the graph. What are possible combinations that would make this inequality true? All right? So like anything in the green. So I could have 200 pounds of plastic. And let's put this little dot right here. And 50 pounds of paper. See, that would fall under that region, right? I could have, let's look at another spot. 450 pounds of plastic and 50 pounds of paper. Actually, is that 50? Yeah. So, what I'm trying to say, guys, is any point, I mean, if you were to pick any point inside here, you can get all types of ordered pairs that would make it true. Okay? But would anything outside of that be a solution? No. So it's significant as a student to understand, hey, this is why I'm learning how to graph these inequalities. Because there's different ways to model them. Okay? All right. Take a peek. Everybody look at, let's see here. We're going to look at the last, number 5 together. Because this will be a nice one to discuss. And then I might let you guys loose if we're picking up on this. Okay? So here's another business model. I'm going to have, let's see here. We'll have Grace read this one for us. Okay? Go ahead.
Is a very successful social media and business consulting firm. Several times each quarter, the company pays for each employee's 1 hour massage and 1 hour personal training. Is it massage or message?
A massage.
Alright.
Yeah, sorry. Yeah.
Session at a local gym costs $40. It skipped like a whole sentence. While each personal training session costs $30. However, the company's total cost for providing these services could not exceed $6,550 per quarter.
Per quarter. Okay. All right. So the first thing I want to ask you guys is, do we understand the business model? Okay. How is this company making money? So, Vivian, can you maybe tell us, have some input? Like, how is this company making money?
Making money because they're very successful, but by the way.
True. So, like, what can we need more detail? Like, how are they making money, and what avenues?
Oh, by like social media and business consulting.
Okay. So they're charging massages for what?
130.
Each massage is
I'm so sorry, 40.
$40, right?
Personal training.
And personal training sessions for $30. So basically, they're going by the number of, obviously massages and training sessions, and that's how they're making their bank. Okay. Now, obviously, there's other costs associated with this business, but as in general, I want you guys to look at this word here, cannot exceed. I want you to underline that. Okay. You see how? And here's what we got to understand here. Okay. Does this inequality make sense to the business model?
Yes.
What's the 30 in front of, or 40 in front of the X mean? $40 per massage. Okay. What's the 30 in front of the Y mean?
$30 per training.
$30 per training session. Okay. Why do I have this less than or equal to sign?
Because it can't exceed that.
It can't exceed that first quarter revenue. That value. Okay. So what we got to do here is we got to say, all right, what form is that equation in? Standard form. But it's an inequality. All right. So now I want you guys to make sense of this. We're going to label the X and Y carefully. The X represents the number of massages. Okay, where the Y represents the number of personal training sessions. Okay, so now we're understanding, oh, you know what, all these abstract algebraic things I'm doing, these graphs, they come from business models. Okay? So what we do is we say, all right, what's our domain? Sometimes it's a fancy word for what's your X values limited to. Well, you got to find the X-intercept to find how the highest X value you can go up to. All right? So here's what we got to do. To get the domain, block off the Y. Okay? What's your X-intercept? 160. So your X-intercept is at the location 160. Is it right at 163?
Yes,
0.75.
0.75, comma 0. Okay. The So what does that mean? As a domain, you write it like this. A reasonable domain in that compound notation would look like this. All x values from 0 up to 163. Okay? See, why would I stop at 163 as a reasonable domain? You can't, like, it's a 0.75, right? Is your x-intercept? So in other words, I have to understand as a student that I can get up to 163 massages, or not as a student, but as a, a client. You get 163 massages under this business model. All right? Now, in interval notation, that would look like this. 0, 163, bounded on both ends. So it's just a way to express your reasonable x values. Okay? So can you guys tell me how you find the range? What would I need? What's the significant value to get the range? I'm going to need the y-intercept. You guys see that? So all I do is block off the x and divide to get the y. So what's our y-intercept? All right, so we'll jot down our y-intercept is 0 up 218.3 repeating. So the range in our mathematical notation would look like this. All y values from 0 up to 218 personal training sessions. See, that this compound inequality tells us the max number of personal training sessions I can get. Okay? So, let's make sense of this. Now we have our nice pretty inequality up here. Okay? We're going to test some possible combinations. Because our revenue can't exceed a certain value. And that probably has to do with the number of people working at the business, the costs associated with running the business. All right? It would be nice to exceed it because you make more money, but also there's restrictions to that based on how much people you're hiring and things like that. Okay? So here we go. In the past year, Life Trace provided 100 massages and 83 personal training sessions for the first quarter, 67 massages and 130 personal training sessions in the second quarter. Did the company exceed their quarterly budget at any point? How do you check that? You plug the XY values into the inequality. All right? So we're going to take this first XY point, plug it into our inequality. So 100 goes in for X, and 83 goes in for Y. And we want to validate that, is that a true mathematical statement? Okay? Let's crunch the numbers on the left. All right? What do we get? 4,000 plus 30 times 83. A big number. We'll make sure it's less than 6,550.
6,490.
All right. So what happens here, ladies and gents, is that this combination passes the test. So you could offer 100 massages and 83 personal training sessions because it falls under a true statement. Okay. Now, let's do the second quarter scenario. What if I had 67 massages combined with 130 personal training sessions? Crank out those numbers. Okay? Let's see if we produce a true statement. So what do we get this time? So we know the right side's 6,550. What's that left crank out to?
2,680.
How much?
2,680.
Okay, that's just for that part. And then go ahead and add this one to it. Yep, so we'll add the 30 to.
6,580.
Oh, so interesting. So they all add up to 6,580. What does that mean, ladies and gentlemen? That means they exceeded their budget in the second quarter. So this one This one was good. So this one says no, didn't exceed. Okay, you're good there. But obviously this guy, yes, it exceeded the budget. Exceeded the budget. Okay. So, are you guys appreciating the relevance of what you're learning then? I mean, that's the thing. We want to make sure we're seeing that. So, the last thing I'd ask for you to do in this situation is let's graph our model. So, we got 40x plus 30y is less than or equal to 6,550. And I'm going to get you set up on the graph. And it's very similar to what we just established. But here's the deal. All right? When you graph, always label your axes. Always. Okay? So what would go on the x-axis then? The number of massages. And then the y-axis would be the number of training sessions. Mm-hmm.
Is massages spelled the same as messages?
No.
Messages would be MESS. AGES. Okay. Yeah. So yeah, be careful there. So let's scale this correctly. Notice the x-axis. We already have the x-intercept right here, 163.750. What would be a nice, pretty x like spacing? So like, what would you guys do? Like 25 maybe? Is that pretty a pretty spacing? Yeah.
You just put like 0 and that number at the end, and then 0 at the end.
Yes, but you do want to scale your axes where it fits nice. Okay, so I get it. So let's go by 25s on the x. So here's 100, 125, 150, 175, 200. We're only going up to 163 on the x-axis. So all we gotta do is put a dot at the estimated location. That's right about here. There's our x-intercept. Okay? Yeah, no problem. Now, the y-axis, Alexa, can you give me a nice pretty spacing for the y-axis, you think? So you go up to 218. By 20s or 25s, either way. So let's do that 25 thing again, okay? So we go 25, 50, 75, 100, 125, 150, 175, 200, 225, okay? So on the y-axis, we put a dot at 218. That's about right here. Solid or dotted line? What would you guys say from our equation? Solid or dotted? Solid line, very good. Because of the equality, okay? And then we have to ask ourselves, do we shade above or below the line? Below. Below. So this green stuff, all this green stuff, is our possible scenarios we can have under that budget constraint. So I could have 50 massages and 50 training sessions, right? I could have 125 massages and 50 training sessions. As long as everything falls below that feasible region, we're good. Okay? Next question. What's the reasonable domain in this scenario? We just answered that, didn't we? 0 up to what? So the reasonable x values would be 0 up to 163, right? What's the reasonable training session? 0 up to 3. Very good. Okay? All right, here's the deal.